Welcome to the project demonstration of solar buck converter using PIC microcontroller. So in this project mainly we are using PIC microcontroller to measure the voltage which is getting from the solar panel through this regular power supply board, as well as the output of this solar panel is input to this buck converter. So the purpose of the buck converter in our project is, as we are using the 4 volt 1 amp battery but we are using the 9 volt solar panel. If you want to charge up solar for 4 volt 1 amp battery, then we need to provide the 5 volts maximum and 4.5 minimum, and so that the microcontroller will buck the voltage if the voltage is more than 9 volts, more than 5.5 volts, then it will do the buck operation to make that voltage in between the 4.5 to 5 volts, and that will be achieved with the help of this buck converter, and based on the pulse signals will be generated from the PIC microcontroller based on the input voltage measured through this voltage sensor. And once the voltage sensor level output to the microcontroller reaches 4.5 to 5, then it is normally provide the MOSFET continuously on. And when it crosses the 5.5 voltage is more than that, means when the solar panel voltage is above 5.5, then the system will reduce the on time signal to the MOSFET, so that with the help of this inductor and the capacitor the voltage will be reduced. Whenever the voltage is reduced till below the 5 volt to 4.5, in between that, then system will stop reducing the on time to this MOSFET. And this is a continuous process, as it's a closed loop. Inputs and output of this buck converter again input to the microcontroller, and parallelly we are providing that to this 4 volt 1 amp battery to recharge that. And we have interfaced the voltage sensor at A0, which is a 10:1 potential divider voltage ratio. Whenever the input voltage is 10, the output of this voltage sensor is 1 volt. And the next this is a 5 volt directly for interface to the A1 pin, and C0 pin interface to the MOSFET for the buck operation, and B2 to B7 LCD. Let us see the demonstration directly. As you can see, this regular power supply board consists of 4 diodes which will act as a full wave rectifier. And the purpose of this full wave rectifier is, when we are providing DC, this full wave rectifier will act as a polarity corrector. Means if is there any reverse polarity occurred, means reverse polarity connection was placed input to this one, then this polarity corrector will rectify that to plus, minus to minus, and after the filtration the output is directly to the our microcontroller board through the buck converter, and microcontroller board will do the buck operation. Let us see the demonstration just beyond the power supply, as welcome message will be displayed on the LCD screen. You can see this. Right, input voltage is 4.3, so it slightly do the buck operation percentage based. So just we are placing the lighting on this, and the voltage will be bit increased. Right, if you place the solar panel under the full sunlight, then we get the more voltage. When it reaches above 5.5, then the voltage should be locked to 4.5 to 5 volts only. That is sufficient to charge our battery pack. So we are using the closed loop buck converter by using the microcontroller. Thank you.